Hello everyone, welcome to my video tutorial on AWS Relational Database Services. As we know, database is one of the core component of any application. Today we are going to discuss about the important relational database services that AWS provides. Before I start my tutorial, I'm a blogger and I write my blog at techieandtravel.com. Do check it out. Also, if you like my YouTube contents, do like, share, subscribe and comment on it. So let's look into the overview. We will talk about various database concepts. We'll talk about the data structure and all. And then we'll jump into Amazon provided relational database service. We'll also discuss about the cloud native database service that AWS provides known as Amazon Aurora. So this tutorial will specifically focus on Amazon relational database services. So when we talk about leveraging any of the Amazon provided services, those services can fall under any cloud computing models. We have infrastructure as a service, platform as a service, and software as a service. I have a detailed YouTube video on cloud computing model as well, so do check out that. With AWS database services, you have the flexibility to choose the computing model type. So you can choose infrastructure as a service where you can get maximum control over the infrastructure where your database is running. If you leverage this model, then you can choose your own EC2 instance and you can deploy a database onto it. But this is where you have to maintain the entire infrastructure, the health of the servers, etc. However, if you just want to control the database layer but don't want to manage the underlying infrastructure, you can leverage platform as a service. You will have control over the database layer and Amazon manages the infrastructure layer. You can do that with Relational Database Service or RDS in AWS. So AWS created RDS to reduce the management overhead of running a database in EC2. With just few clicks, you would be able to leverage and deploy the Relational Database Service. Amazon RDS provides an option to choose from multiple database engines, in particular 6 engines, out of which the commercial side you have Oracle and Microsoft SQL Server. On the open source side, you have MySQL, PostgreSQL, and MariaDB. And then you have cloud native database service called Aurora. We'll discuss about Amazon Aurora in a bit. And then there is software as a service approach, where you have minimal control over the infrastructure as well as the database layer. So you just leverage database as a software. Some SaaS database services that are available in AWS are DynamoDB, Elasticache, Redshift data warehousing, etc. So first important factor in database choice are data types. So when you hear the word database, the first thing that likely comes to mind is a relational database with its row and column structure full of data. So these data can be structured data, which has clearly defined types with patterns. And these structured data can easily be broken into column of properties. These individual properties can be compared, they can be sorted, or they can be searched. For example, data types like phone number, social security number, zip codes, etc. falls under structured data category. Or data can be unstructured. Unstructured data are stored in their native format, and since they are stored in their native format, which can be of any type, so it requires some expertise analyzing. Unstructured data are more like freeform, like body of email, images, videos, or some machine-generated images like satellite images, or some scientific data like space exploration data, etc. And this type of data contains some structured metadata as well, but the content itself contains wide variety of information that cannot be easily broken into rows and columns that we did with structured data. And then there is document data, just like JSON document, which are used by applications to communicate. In document data as well, there is some structure, but not something that would fit nicely into the relational database column. So in this tutorial, we'll talk about relational database, which leverages the structured data. I just wanted you to understand the difference between structured and unstructured data and what's the difference between relational and non-relational database. So the first is Amazon Relational Database Service or RDS. RDS is a mature technology. It's easy to understand and it takes platform as a service approach to run database that we can leverage within our applications that are running on our platform. So it's a fully managed service, which means Amazon manages the database by taking care of core things like provisioning server, patching, backup, recovery of your database, etc. And you can just focus on developing the application instead of administrating it. You can create RDS instance using several different database engines, including Oracle DB, MySQL, PostgreSQL, MariaDB, Amazon Aurora, and Microsoft SQL Server. And since it supports these many commercial and open source database engines, it makes it really easier for you to move your existing relational database to the cloud without having to change your database engine. But remember, each database engine has its own pricing model. RDS synchronously replicates data to the standby instance. So you have a primary instance and a standby instance with RDS. And synchronous replication is where the data is written to the primary storage and the replica simultaneously. So the primary copy and replica are always synchronized. Now let's look at some RDS features. RDS provides you the ability to choose the instance size. So you can select instance based on compute, your IO needs, or some memory needs. And then you can choose a small instance and have some cost savings for applications that has light database load. Or you can choose large instances for application that needs higher performance. And as your application load increases, you can easily scale it to run to some larger instance size with more resources. RDS has several helpful features for storage management as well. You can use storage auto-scaling to automatically increase your available storage space as your storage starts to fill up. You can easily backup and restore to new instances, and you can schedule backup as well. RDS provides high availability by allowing database instances to be created in multiple availability zones. So multi-availability allows you to create an exact copy of the database in different availability zone other than the primary database instance. So as data is written to the primary database instance, it's automatically replicated to the secondary instance, which is in different availability zone but within the same region. And replication is synchronous. So in synchronous replication, as I said earlier, data is written to the primary storage and replica simultaneously. So since primary and replica copy are always synchronized, database can be failed over to the secondary automatically without any manual intervention. And during automated failover, the standby instance is promoted to the primary instance. And this is done by updating the DNS CNAME record of the database endpoint of master to reflect to the endpoint of the standby instance. You don't have to do anything else other than updating the DNS CNAME record. So multi-availability zone setup is for high availability and disaster recovery rather than improving the performance or scaling the database. So one option to scale the RDS database with read-heavy workload is to create read replicas. So this is one of the primary feature of relational database in addition to the high availability setup. So it allows you to have a read copy of your primary database, and the data is automatically replicated asynchronously from the primary database to the read replica copies across multiple regions. So we learned that in synchronous replication, data is replicated to primary and secondary database simultaneously, but in asynchronous replication, data is copied to the replica only after data is written to the primary storage. And these read replicas, they route read heavy traffic away from the main database instance, reducing the workload on that specific instance. But read replicas can only be used for reading the data, and it cannot be used to write the data because data is written to the primary database instance only. And you can create up to 5 copies of read replicas. And these read replicas can be used for scaling. And it is not designed for something like high availability or disaster recovery. But read replicas can be promoted to the primary instance for faster recovery in case of any disaster. But with all these features that RDS provides, there are certain challenges as well. The first one is data traffic and load handling. Is your database compute power sufficient to handle the load and traffic and queries that come into the database? Another is cost. You have to take into consideration if you can save cost for the unused time or some ideal periods where your database is not running. Or are there any high upfront licensing cost? Next is, how does your database mitigate the hardware failure so that you won't lose any data? Next is the difficulty in database administration. So to handle all the challenges of RDS, Amazon created a Aurora database, which is the first cloud database. So let's dive deep into it. Aurora is a database engine developed in RDS. So it's not like a MySQL database that you can run and deploy in any infrastructure or servers. It can only run on AWS infrastructure. So it's a cloud native relational database that is designed to solve the challenges we discussed earlier by leveraging the cloud features. And Aurora is MySQL and PostgreSQL compatible. So there is no new language or any specialized tools that you need to learn. And much of the database administration is built in and is automatic. Relational databases were not designed for the cloud with their multiple layer of functionality in a single monolithic stack. But Aurora database has a distributed design. So storage layer is separated. So rather than running the entire database on some fleet of EC2 instances, Aurora splits the compute and storage into different pieces. So storage is handled by the custom data layer. So an Aurora database cluster has multiple database instances and cluster volume for managing these instances. And these cluster volumes are nothing but database storage to store the data. So every cluster in Aurora database has a primary database instance, and this primary database instance takes care of performing all the data read and write operations on the cluster. And the Aurora replica, it only supports read operations, and it connects to the same cluster in which the primary database instance connects to. So if the primary database instance fails for some reason, Aurora replaces it with Aurora replica. Hence, it's more resilient and has fast recovery from failures because all the data nodes has the same shared state of cluster, and it can start new read replicas with minimal lag, and if one writer fails, then another replica can be promoted to take over. Aurora is more durable because data, which is the core component of database, is stored in a shared cluster volume. Aurora actually makes 6 different copies of data across 3 different availability zones. And in addition to that, it continuously backs up the data to S3 as well. So Aurora has high performance and scaling ability. So one important part of the database is the number of read replicas. So the primary database is the read-write instance, but in addition to the primary database, it has replicas, which is exact copy of the primary. And updates from the primary instance are made visible to all Aurora replicas. So for example, for read intensive applications, Aurora can have up to 15 low latency read replicas across 3 different availability zones. And each Aurora database instance can also handle up to 128 terabyte of database storage. So Aurora scales faster because it can add new replicas quickly. And another important benefits of using Aurora is it is cost effective. It is almost 1/10 of the cost of commercial database with same performance and feature. Aurora also supports serverless option, which can automatically scale compute nodes up and down based on your usage, so that you don't have to worry about over provisioning or under provisioning your instances. This is particularly useful if you have spiky, intermittent, or unpredictable workload. You only pay for compute capacity that you use, so you could enjoy some big savings if you have some long idle periods where you don't use your database. You can also monitor the database performance by using Amazon CloudWatch, which is a tool that is used to detect performance problems easily. But obviously, as with the other database services, Aurora has certain limitations, like it supports only 2 database engines, whereas RDS supports 5. So if you need MariaDB, Oracle, or Microsoft SQL, RDS is your only option. Also, if you want to use AWS free tier, you can use it with RDS, but you can't do that with Aurora. So this is it on the relational database services that AWS provides. We covered in-depth understanding of Amazon RDS and Aurora. And if you like my contents, please like, share, subscribe, and comment on it. I'll cover further more videos in my upcoming tutorial. See you then. Thank you.